course on Python machine learning. In this course, we are going to use Anaconda. It's a bundle of the basic machine learning libraries we are going to use throughout this course. You can download the favorite Anaconda bundle for Mac OS, Windows, or even for Linux. We stick to Python 3.6 for this course. So after downloading and installing the Anaconda bundle, you can use the Anaconda navigator or simply go to your terminal, and all you have to do is type down Jupyter Notebook, and afterwards what you get is a similar screen like this one, and you shall find the notebook list over here. In this notebook file, we had some snippets that are going to help us throughout this tutorial from Python, from Matplotlib, SciPy, NumPy, and scikit-learn. We'll start with the basics of Python programming. It's quite conventional to define a variable with writing the variable name, anything you can think of, equals then the object you are trying to build. So we are assigning here ls to a list. Lists in Python are defined using square brackets, and inside the brackets you have all the elements of the list. Two other types of collections, data structures in Python are tuples, and they are defined this way. Like you can have a tuple with parentheses, and the tuples are immutable data structures, and you can have dictionaries. Dictionaries are defined with curly brackets, and they have key values, and that's the equivalent of hash map in Java or hash test. You can find A is equal to 1, B equal to 2, and that's quite it. In Python Jupyter Notebooks, all you have to do to run a cell, this part we call a cell. We have different kinds. It could be code, markdown, or something else. The keyboard shortcut shift enter. You simply run and initialize the variables in the cell. Next, just like any other conventional programming language, we have a for loop. In the for loop, we have for every element I in the ls, print I. As simple as this. We can index the list by using numeric values. It could be 0, 1, 2, whatever number we are trying to get out of the list. But be careful, because out of index or out of range boundaries can be broken here. There is no real-time checking. Like this one, it's a list index out of range. So be careful with this kind of operations. One precautionary step before indexing directly into an array could be to use the list length, and that's very simple as len of ls, and that will print out the list size. Here it's 4. Next, we see how to append to a list in two different ways. ls.append, that adds an element to the list. Here it could just be 99. Running this and then printing out our list, now we can see that 99 has been appended to the end of our list. Different syntax, different ways for extending the list is ls.extend. But be careful, because if you remove these parentheses, you are going to get an error, because extend works with extending one list with another list. Let's see how this works. So here you can see that 99 has been appended one more time to the end of the list. Just for fun, let's see how if we try to do the same with append. If we try to do the same with append, it should work, but here instead of appending the raw element to the end of the list, we can see that another list, as a nested list, has been appended to the end of the list. Of course, this is not what we really want. Let's rerun. I believe we have to rerun this code with extend so that it doesn't break up our following code. Well, it's still there. Let's start all over again. Just quickly remember that very handy the keyboard shortcut is Shift Enter to run everything. Here we are. There is also another here shortcut in kernel, start and run all, but we don't really want to do that. Next, we define a function. Function definitions are we combine a few lines of code into a reusable subroutines that we can invoke later in our code in many different places without having to write everything all over again. It starts with the syntax define, def, the function name, then round parentheses, and inside the parentheses we have parameters. Conventional programmers used to pass parameters with underscore just indicate that these are parameters passed from the outer scope. Inside the odd even function we have a for loop that is very similar to the one we had over here. For I in ls, print I. For I in ls, if I modulus 2 equals 0, that means if we divide I by 2 and then the output of the division operation leaves no reminders, that means I is divisible by 2. Very basic arithmetic from elementary school. You may need to refresh your knowledge on that part. But that's the syntax for modulus or reminder. And if it is equal 0, that really means that I is an even number. So we print that out, print parentheses, some string placeholder, and we'll talk a little bit about placeholders in string formatting, is even. And here we see the modulus operation again, but here it's not really the arithmetic modulus operation. It is the formatting in Python 3. So we are saying here instructing Python or the compiler to replace the placeholder defined by curly brackets with a value that is to be prepared later and that will be fetched from the variable I. We will fetch the value of the variable I, replace it here instead of this integer. D is for integer, F is for float, and S for string. So it's just a way to keep your code clean. Else, if I modulus 2 is not equal to 0, that means it is odd number, print that the I integer is odd. Here we could have just said else without having to rewrite our condition once again, but I just left it so that you know the syntax for if and else if. Let's run this code. Here we have our list again, just to make sure what variables are inside our list. Now let's pass this list as a parameter to our odd even function and inspect the output. So here you can see that 1 is odd, 2 is even, 3 is odd, 4 is even, 99 is odd, 99 is odd. That's pretty much it. Here we define another function, and that function we call it square underscore x, and what it does is given any integer x, it will just return the power 2 of that integer. Wanted to show you the syntax of how to do that is x asterisk twice, that means x power, and any number here is 2. We could also have 2 as a parameter over to the function so that it could become quite generic, but there is no point of showing that over here. I think we have the point clear. Another interesting way for defining lists in Python is using the square brackets, and inside the square brackets we can just do this shorthand syntax. So we are saying invoke the function square x given the parameter I. What is I? I here it means for every I element I in the list ls, and that's pretty much the same of having the square it invoked on every element inside the for loop in rather long and clumsy syntax. Inspecting many of the Python open source libraries, you'll find these shortcut codes used quite often, so get accustomed to them. Let's conclude this session up to here, and the next session we shall start with Python object-oriented programming. And thank you for listening.